Hi everybody, and welcome to the first tutorial in a series that will guide you through building your own 8-ball pool game using JavaScript and HTML5. So before we begin, I would like to take some time to give a credit to a book that I read that inspired me of making this game. This book is called Building JavaScript Games for Phones, Tablets, and Desktop, and it is written by Arjen Egis. I'm sorry if I'm pronouncing the name wrong. Anyway, it is a really great book, and many of the topics that I'm going to talk about during these tutorials are taken from here. And if you would like to gather deeper understanding and knowledge about those topics, I really recommend you to read this book. You can have a look at my code by getting to my GitHub page and find this repository that contains all the code for this project. You can even go down here and you'll find a working demo that you can enter and play and experience the game all by yourselves. Alright, so let's move on. So the first thing we will do is to create a new folder for this project, and maybe we should give it a significant name, something like classic pool game. Now I will open my preferred text editor, which is in my case Visual Studio Code, and drag the newly created folder into it. Let's now create a new file. And the first file I'm about to create is the HTML file. Let's give it a name, index.html. Now, there are many neat ways to create the structure of an HTML document with Visual Studio Code. You can just write HTML and choose this option, and you'll see that the structure is already built for you. But I'm going to delete all that since I promised to show you how to build a game from scratch. So I'm going to write everything myself. Let's start with the HTML tag, and inside of that I will create a head tag and a title, and let's give it the same title as the folder name, classic pool game. Let's create a body tag, and here we will create a canvas element which will have an ID of screen and width that will change in the future since the canvas is going to be adaptable to the screen size, but as of right now I'm going to keep it 2000. Height will be 800 for now, and that's it. The HTML document is pretty much complete for this game. After we've created the canvas element on our HTML file, let's now create a JavaScript object that will let us interact with this canvas. In order to do so, we will need to create a JavaScript file. Let's call this file canvas.js. In this file, I'm going to define a function constructor. And let's call this function constructor canvas 2D. The object that eventually will be created using this function constructor will have two data members. The first one will be this.canvas, which will be the canvas itself, and I'm going to fetch that from the HTML using document.getElementById, and here I'm going to send the ID that I gave to the canvas before, screen. As you can see, it is the same ID as the canvas on the HTML file. So the second member is the canvas context, and the canvas context is an object that has certain functionalities that will make our lives much easier interacting with the canvas. So in order to get the canvas context, we'll need to approach the canvas element and ask for the context. Get context. Here I'm going to send 2D since the game is going to be two-dimensional. Let's think about the functionality we would like a canvas 2D object to have. As of right now, I can think of two things. I would like to clear the canvas using this object, and I would like to draw an image on the canvas using this object. In order to define this behavior, we will need to use methods. I will define the methods on the prototype of canvas 2D. Let's do it right now. So canvas 2D.prototype.clear equals a function And here I'm going to use the clearRect function of the canvas context. Let's write canvas context dot clearRect, and it will need to get an x value and a y value, a width and a height. So the x will be 0 since I want to clear all of the canvas, and the y is 0, and the width will be the canvas width dot width, and the height is going to be the canvas height, canvas dot height. All right, so let's move on to the draw image method. I'm going to define it here, canvas2d.prototype draw image, and that will be equals a function that will get an image and a position, and it will use the canvas context to draw that image on the given position. So I will need to approach the canvas context and ask it nicely to draw the image for us. I will send the image that I got, and position dot x and position dot y. So the next step is to see that everything that we've done so far is actually working as expected. In order to do so, I will go to the index.html file and add a reference to the script that we just wrote. So script src, and that will be equals canvas.js, and that's it. The second thing that we'll need is an image to check the draw image method. And I already dragged the assets folder into the new folder that we've created for this project. In order to find the assets folder, you can go to my GitHub page. I will leave a link down in the description below, and you can download the assets. Alright, now that we are ready, let's create a new object using the function constructor that we built before. So let's call this object canvas, and it will be equals a new canvas2d object. Now, in order to test the draw image method, I'm going to create a new image. So let's call it image, and just to make it clear, I will comment here that it is just for testing. Okay, so here the image will be equals a new image, and here I will need to define the source for this image, the path of the image, image.src, and that will be equals, and I know the path, but if you want to make sure, you can just open the assets folder and see where this image is. So I will write it down. It's dot slash assets slash sprites slash spr background dot png. Alright. There is an issue that we need to consider here, since it's gonna take a while for the image to load, but the script is going to be rendered immediately. So we cannot just write something like canvas dot draw image and just send the image and the position that we want, because that just won't work. If I open the index.html file, you see that nothing is displayed on screen, even though we have no errors. So only for testing and to see that everything that we've done so far is working, I will set a timeout down here below, and inside of the callback function I will paste this code and set the timeout for 1 second. And let's see if now that that is working. Yes. Okay, so now you can see that the background image is displayed on screen. Let's check the clear method that we wrote before. So I will just write canvas.clear, and let's refresh the page, and you see now that the canvas is empty. So let's go back to our code and delete this line because I prefer to see something displayed on screen before we finish the first part. And let's see that everything works. Yeah, great. As you can see, the background image was drawn on the canvas, but there's only a minor issue. You can see that the image is a little bit cropped down here. So in order to fix that, I will change the dimensions of the canvas to match the dimensions of the background image. So the width should be 1500 and the height should be 825. Now, as I refresh the page, you can see that the image is no longer cropped. So let's go back to our code and delete all those lines we used for testing. Let's save and now create a new JavaScript file that we'll call assets.js. Here, eventually, I'm going to declare functions that will help me deal with loading the assets for the game. But first, I'm going to create a new object, and let's call this object sprites. And it will be equal an empty object. Let's create another variable that we'll call assets still loading, and let's set it to 0. Let's declare a new function, and let's call this function load assets. And this function is going to take as an argument a callback function. So once it finishes to load all the assets, it's going to activate this callback function. Here I want to write something like sprites.background equals load sprite, and I want to pass the file name which is located on the sprites folder. In my case, that will be spr_background.png. In order for that to work, I will need to declare another function here, and I will call this function load sprite. And this function will take as an argument a file name. And the first thing it's gonna do is to increase the number of assets that are still loading. Then I will create an image for this sprite. Sprite image equals new image object. And I'm going to define the source of this image to be the path of the sprites folder, which is assets/sprites/ plus the file name. Now I'm going to use the onload property of the image object, and I'm going to define that once the image is done loading, I want to decrease the number of assets that are still loading. Now I will return the image. We can use the load sprite function that we just wrote to load all the sprites of the game. But for now, I will load just one more. So sprites.stick equals load sprite. And I will send the file name of the stick image. So that will be spr_stick.png. And we cannot activate the callback function yet because we cannot know for sure that all the images are downloading. In order to validate that, we'll need to create another function, and I will call this function assets loading loop. And this function will get as an argument the same callback function that we received on the load assets function. Inside this function, I'm going to do something if assets are still loading, and else I'm going to do something else. So if the assets are still loading, I want to enter the loop again. So I'll use the requestAnimationFrame method of the window object in order to send the assets loading loop as a callback function, and I'm going to bind this and the argument that I got, which is the callback. Else, I want to activate the callback function. So I will just call callback. Finally, we'll need to call the assets loading loop from within the load assets function. So let's just copy that and paste it here. And let's just send the callback function that we got as an argument. And that's it. Well, for now, that's pretty much what we need in assets.js. We're going to use all the code that we wrote here very soon. Let me organize my code a bit before we move on. So I'll just delete some of the spaces here and add more spaces here and maybe there. Alright, so we are done. Now let's create the most important object on our project. And for that, I'm going to create a new file and call this file game.js. And here I'm going to define a function constructor and call this function constructor game. The game object will contain 3 methods. Let's write them down. So the first one is game.prototype.init. So here we will initialize the game. The second one will be game.prototype.start. So you can imagine that here we will start the game. And the third one is game.prototype.mainLoop. And in this function, pretty much everything is going to happen. Before I write anything inside those methods, I want to create another object, and this object will be called the game world. Let's create another function constructor and call this function constructor game world. The game world will be an object that will contain all the physical objects of the game, and in each frame of animation it will be responsible to update them and to draw them on the canvas. In order for him to do that, we'll need to define some methods. So the first method will be the update method, and the second method should be the draw method. Now I'll go back to the game.js file, and here on the init method I'm going to create a new member for the game object, and I'm going to call this member game world, and this game world will be the new game world object that we created. Now down here I'm going to create a new object that will be of the type game. So I'm going to call this object pool game, and it will be equal a new game object. Let's now deal with the start method of the game object. So here the first thing I want to do is to call the init function, and then I want to call the main loop. And on the main loop, the first thing we want to do is to clear the canvas, and for that we can use the canvas object that we created in the previous video. So just write canvas.clear. After that we want to update the game world, so we can just use pool game in order to approach the game world, and then to call the update function. And then we want to draw the game world, so we can go to pool game.gameWorld.draw, And then we'll use the requestAnimationFrame method of the window object, the same method that we used before, to call the same loop. So let's just write requestAnimationFrame, and we can call poolGame.mainLoop. Now I'll go back to the gameworld.js file, and here on the draw method, I'm going to use the canvas object in order to draw an image, and the image will be the background image. So sprites.background, and the position will be x will be 0 and y will be 0. The next step is to open the index.html file and to add references to all of the script files that we wrote. So I won't waste your time, I will just paste that here. And another thing that we'll need to do is to write a small script, and in the script I'm going to call the load assets function that we wrote, and as a callback I'm going to pass poolGame.start. So when it finishes loading all the assets, it's going to call this function, this method on the poolGame object that will start the game. Let's try and open the index.html file on our browser, and let's see if we get something. Well, no. Let's check for errors, and yeah. This .init is not a function. Add game.start. Oh, okay. So this is a common issue in JavaScript. What happened here is that we passed a function to another object to activate, and in this process the this reference changed. So now the this reference is no longer the pool game, it is the window object, because load assets is a function that sits in the window object. In order to fix that, we need to go to the game.js file, and here instead of calling this.init, we'll call poolGame.init and poolGame.mainLoop. Let's go back to our browser and refresh, and now you can see that the background image is displayed on screen. To make it interesting, let's add another object to our game. I'll go back to our code, and here I will create a new file, and I'll call this file stick.js, and another function constructor, so function stick, and the stick object will have for now a position. So this dot position equals x will be 0 and y will be 400. The stick object will also have an update method and a draw method. Let's write them down. So stick.prototype.update equals a function, and stick.prototype.draw equals a function, and inside the draw function I want to call the canvas object and to draw an image, and the image that I'm going to draw is the sprite of the stick that we loaded before. So sprites.stick. I want to draw it on the current position of the stick. So let's use this dot position. Inside the update method, I just want to write some stab code in purpose of testing. So let's just leave a comment here, and I will mention that it is just for testing. And I'm going to increase in every frame of animation the x value of the position of the stick by 1. So this dot position dot x plus plus. Now in our game world, let's add a member, and this member will be the stick, and it will be a new stick object, and inside the update function I'm going to call this dot stick dot update, and after I will draw the background image, I want to call this dot stick dot draw. The final step for now is to open the index.html file and to add a reference to the stick.js file that we wrote. So script src, and here I'm going to write stick.js and save it. I will open the index.html file on my browser, and now you can really see the main loop in action. So let's delete those lines of code that we use for testing. Let's save and now create a new JavaScript file that we'll call vector2.js. Here I will define a new function constructor that its purpose is to help us deal with arithmetic operations between vectors. Let's call this function constructor vector2, and it will get two arguments. So the first one will be an x and a y. A vector2 object will have two members that goes by the same names as those arguments. So let's write them down. This dot x, and it will be equal if type of the x argument is different from undefined, it will be equal the value of the x argument, else it will be a 0. And let's do the same for the y. So this dot y, if type of y is not undefined, that will be equal a y, the y argument, and else that will be a 0. Let's save, and that will do for now. In the future, we'll add more functionality to the vector2 definition. Let's now create a new folder and call this folder input. And inside this folder, I'm going to create a new file that I'll call buttonstate.js. The button state object will be a simple object that will indicate whether a certain button is pressed or down. So let's create a new function constructor, and call this function constructor a button state. And let's initialize this dot down to be false, and this dot pressed to be false. Now I will create another file inside this folder, and this file will go by the name of mouse.js. Here obviously we will handle our mouse input, and for that I will need a mouse handler. So let's define a mouse handler object, and the mouse handler will contain 3 button states, one for every button on our mouse, and a position that will be of type vector2, the type that we created before. So let's write it down. This dot left equals new button state. This dot middle equals new button state, and this dot right equals new button state object. Now the position, this dot position, will be initialized to a new vector2 object. And now I will define that once there is a mouse movement, so on mouse move, we'll call a function that will write just in 1 second. So I will call this function handle mouse move, and document on mouse down, I will call another function handle mouse down. And finally, document on mouse up, I will call handle mouse up. Let's save. Alright, so now let's create a new object of the type mouse handler that we just defined. So I will call this object mouse. Let mouse be equal a new mouse handler. And now I will implement the functions that we wrote here. So handle mouse move, I will just create a new function and I will call it handle mouse move. And by default, it's going to get an event. So let's fetch from the event the mouse position. So we can get the mouse X value by going to the page X property inside the event object. So let Y be equal the event dot page Y. And now we can set the mouse dot position to be a new vector 2, and send the arguments X and Y. Let's save. Okay, so let's move on to the next function, handle mouse down, and this function is also going to get an event as an argument. And before I write anything inside this function, I want to call the handle mouse move function and send the same event, so I will get the current position of the mouse. Then let me paste a little bit of code here, and then I will explain exactly what is going on inside this code. If a certain button on our mouse is down, we would like to set the down property of the corresponding button state to be true. We also want to check if the button was down before that, because if not, we want to set the pressed property of the same button state to be true. And also the event object has an attribute that is called which, that indicates which button on our mouse is currently down. And if the which attribute is 1, that means that the left button on our mouse is down. If it is 2, that means that the middle button on our mouse is down. And if it is 3, that means that the right button on our mouse is down. So that's exactly what you see here in the code. I will just fix those underscores here. So let's move on to the next function, and I will just paste that here. And as you can see, it is very similar. We just check the attribute on the event to see which button was released, and we set the down property of the corresponding button state to be false. Just one final thing that we need here is an option to reset the mouse input. So I will define another function, or actually method, on the prototype of mouse handler, and I will call this function, this method, reset. That will be equals a function, and here I want to set this dot left dot pressed to be false, this dot middle dot pressed to be false, and this dot right dot pressed to be false. On our HTML file, I want to add references to all of the script files that we wrote. So I will just paste that here. And another thing that I want to do is to reset the mouse input in every iteration of the main loop. So here, after I draw the game world, I want to call mouse.reset. The last thing I want to do, just to test that everything that we've done so far is working, I want to set the position of the stick to be equal the mouse position. And I want to do something if mouse dot left is pressed. So pressed. So if that happens, I want to log a message. So console.log, and I will just write pressed left. Okay. And I will mention that it is just for testing, as we always do. So now when I open the index.html file on my browser, you could see that the stick object is tracking the movement of the mouse. And if I inspect that, you'll see that every time I click the left button on my mouse, you'll see a new message here in the console. So of course, that's not the kind of behavior we want in our game. But that's an important step because now we know how to handle the mouse input. There is something that bothers me about this implementation, because even though the stick and the mouse share the same position, you can see that the mouse is all the way to the left and it's not on the center of the stick. The reason that happens is because when we draw the stick using the canvas context, we give it a position, and the canvas context treats this position as the top left corner of the image. So in order to fix that, we'll need to introduce a new vector that we'll call the origin of the object. In the canvas.js file, we'll change the implementation of the drawImage method. We'll add another argument that we'll call origin. Before we do anything else here, let's just validate that the position that we got to this function is not null or undefined. So if it is, we should set it to be a new vector2 object, and that will mean that its x and y values will be zeros. Let's do the same for the origin. So if not origin, origin will be a new vector2 object. And now we can use the canvas context save method in order to save the current state of the context. Then we can make changes in it, and then we can restore it to the same state. So this dot canvas context dot save, and now we can translate the context to a different position. So this dot canvas context dot translate position dot x and position dot y. Now in the drawImage method of the canvas context, we don't need to send the position anymore. We can just delete that and instead send the origin. That means where we want to draw our top left corner. So -origin.x and -origin.y, and that's of course relative to the position that we are in right now. And now we can restore the canvas context to the last saved state. So now let's go back to the stick.js file, and let me fix this position to be a new vector2 object, and let's set it randomly to be 400 by 400, And let's add a new property, this dot origin, and set it to be a new vector. And for now, we'll set it to be 500 by 10. And now in the draw method of the stick object, I can just add this origin, and let's see what happens. So let's refresh the browser, and now you can see that the pointer is on the middle of the stick. On the assets.js file, let's load another sprite, and let's call this sprite white ball. And obviously that will be the sprite of the white ball, and the image is located on spr_whiteball.png. Now I will create a new file that go by the name of ball.js, and here I'm going to define a new constant that I'll call ball origin, and I'm going to set it to be a new vector of 25 by 25. Now I will define a new function constructor that I will call ball, and it will get as an argument a position, and I will set this dot position to be the position that we got as an argument. And let's write two functions for the ball object. So ball.prototype dot update equals new function, and ball.prototype dot draw equals a function, and here I'm going to call the canvas and to draw an image. And just for now, I'm going to draw the white balls image, even though not all the balls in the game are going to be white, but it is just for now. And the position will be this dot position, and the origin will be the ball's origin constant. So let's go to the index.html file and add a reference to the script file that we just wrote. So here I will write script src and ball.js. Now let's go to the game world and add a new member, and let's call this member white ball, and it will be equal a new ball object with a new position. On the update method, I want to update our new member, so this dot white ball dot update, and inside the draw method I want to draw the white ball, so this dot white ball dot draw. Back in the browser, let's refresh, and we can see that the white ball is drawn on the canvas. Back in our code, let's go to the stick.js file, and I will change the function constructor of the stick to get a position from outside. So this dot position will be equal the position argument that we got, and also I'm going to define a new constant that I'm going to call stick origin, and it will be equal a new vector 2 of 970 by 11. Now on the draw function, I don't need to send this dot origin anymore. I will send the stick origin, and I'm going to delete this dot origin member. Now I'll go to the game world, and here I'm going to set the position of the stick to be the same as the position of the white ball. And back in stick.js, I will comment out all this code that we wrote for testing. Back in our browser, let's refresh, and now you can see the positions of the white ball and the stick. Don't worry, in few moments you will realize why we did all that. Okay, so there's another aspect that I want to add to the game, and it is the rotation of the stick. And I found this really good article online that explains exactly what I'm going to do in the code. So I'm going to leave a link down below to this article and also explain it briefly. So let's say that here instead of a cat we have a stick, and this is the position of the mouse. So we want to rotate the stick so it will point towards the mouse. How are we going to do that? We need to find this angle for that. So in order to find this angle, we need to find the opposite and the adjacent. And in order to find the opposite, we can subtract the stick Y position from the mouse Y position. And in order to find the adjacent, we can subtract the stick X position from the mouse X position. So we know that tangents of this angle is opposite divided by adjacent. So we can just apply the arctangent function on both sides, and then we can find this angle. Back in stick.js, let's delete those lines of code that we use for testing, and let's add a new property that we'll call this.rotation, and initially it will be 0. Now let's add a new method to the stick object, and let's call this method updateRotation, and that will be equal a function. Now we need to calculate the opposite, so let opposite be mouse.position.y minus this.position.y, and the adjacent be mouse.position.x minus this.position.x. And now we can use the arctangent function inside the math class, so math 8 and 2, and we can send the opposite and the adjacent, and we'll get the angle to this.rotation. And inside the update method, I'm going to call this.updateRotation. Finally, we'll open the canvas.js file and update the drawImage method so it will get also a rotation, and let's give it a default value of 0. And here, after we save the canvas context state, we can rotate the canvas context. So this.canvasContext.rotate, and here I'm going to send the rotation. And inside stick.js, I'm going to send this.rotation to the drawImage method. Let's save and now go back to our browser and refresh. And now you can see that the stick is rotating, so it points towards the position of my mouse. Okay, so let me give you a little challenge. If you code alongside with me, you already have all the tools to implement the next step. Here you'll see that when I press the left button on my mouse, the stick is being pulled away from the white ball. And once I release it, it shoots the ball towards the position of the mouse. So let me demonstrate. Okay, great. So give it a shot. Here in vector2.js, instead of validating that x and y are not undefined, we can just use some default parameters. So let's change that. And x will be 0 by default, and y will be 0 as well. And let's add another method to the vector2 class. So vector2.prototype.copy, and that will be equal a new function. And here I will return a new vector2 with the same properties as this vector. So this.x and this.y. In stick.js, I will bring back this.origin and I will set it to be a copy of the stick origin constant. So stick origin.copy. And in the draw method, I will send this dot origin instead of the stick origin. Alright, I'll zoom in because it's a bit difficult to see the code this way. Alright, that's much better. Now I will add another property that I will call this.power, and I will set it initially to be 0, and I will create another method for the stick class that I'll call increase power, and it will be equal a function, and here I'm going to increase the power but by let's say 100, and the origin, this dot origin, I will increase it by 5. No, actually this dot origin dot x. So now in the update method, I'm going to define that once the left button on the mouse is down, I want to increase the power. So this dot increase power, and let's go to the browser and see the effect that it makes. Okay, let's refresh. And now when I click the left button on my mouse, you can see that the stick is being pulled away from the white ball. Here in the function constructor of the stick, I'm going to send another argument that I will call onShoot. And this argument will be actually a function. So let's set this dot onShoot to be onShoot. And here in the update method, if the left button is not down anymore and this dot power is greater than 0, I want to call this dot shoot, not onShoot. No, I want to call a function that I will define right here, a method actually. So stick dot prototype dot shoot equal a function, and inside this function I'm going to call this dot onShoot, and I'm going to send this dot power and this dot rotation. Now let's open the ball.js file, and here I'm going to add another method to the ball class. So ball.prototype.shoot, and that will be equal a function that will get power and rotation. And just for now, let's log a message to the console. So console.log shoot, and in the game world, when we create the stick object, let's send as an argument this function that we created just now, this dot whiteball dot shoot. Back in stick.js, after we activate the onShoot function, let's set this dot power to be 0. Back in the browser, now you'll see that every time I release the left button on my mouse, a new message is logged into the console. Back in stick.js, I'm going to set another constant that I will call the stick shot origin. And it will be a new vector of 950 by 11. And now in the shoot function, I'm going to set this dot origin to be a copy of the shot origin. Now back in the browser, let's refresh, and now you'll see that every time I release the left button on my mouse, it seems like the stick is moving forward towards the ball. Alright, so in the shoot method of the ball object, we would like to find the velocity that the ball should have. And we get two parameters. The first one is the power, and the second one is the rotation. So in this drawing, let's assume that this is the center of the ball, and here is the position of my mouse. So we know that this angle is the same as the rotation that was sent into this method. Okay, so if we'll assume that the distance between this point and this point is 1, we know for sure that the velocity should be a new vector 2, that its x value will be cosine of this angle, and its y value will be sine of the same angle. Here in the game world, I'm just going to bind this shoot function that we send as an argument to this .white ball, just to make sure that we won't lose the reference to the white ball. And here in ball.js, I'm going to add a new property that I will call this.velocity, and it will be a new vector to object. And inside the shoot method, I'm going to set this.velocity to be a new vector 2, that its x value will be math.cosine of the rotation, and its y value should be math.sine of the rotation. Now inside the update method, I want to add the velocity to the position of the ball. So I'm going to write this.position.add2 and to send this.velocity. And of course that now I need to implement the add2 method inside the vector2 class. So here I will write vector2 dot prototype dot add2, and it will get another vector as an argument. And here I'm going to set this.x to be this.x plus vector.x. So this.y plus equal vector.y, and I need to fix that, so that will be equal a function. And now back in the browser, when I shoot the ball, you'll see that it goes slowly towards the position of the pointer. So now in the shoot method, we can use the power that we got as an argument, and we can multiply the velocity by this power. And in the game world, I'm going to introduce a new constant that I will call delta. And I will set it to be 1 divided by 100. And this will represent how much I want to update on each iteration. So it's a fraction that will send to the update method of the ball. So it will only update a fraction of the velocity. So this dot velocity dot mult, and we'll send the delta. And of course that now we need to implement the mult method on the vector2 class. So vector2 dot prototype dot mult, and it will be a function that will get as an argument a scalar, and will return new vector2 of this dot x multiplied by the scalar, and this dot y multiplied by the same scalar. Now back in ball.js, we can use the same method in order to simulate friction. So we can set this dot velocity to be this dot velocity dot multiplied by 0.98. And now let's test the results on our browser. So let me refresh and let's shoot the ball, and that looks quite nice. So that's it for this video. Thank you very much for watching it, and stay tuned for more. Goodbye.